This is the Math 125 Intermediate Algebra. Today we are going to learn is Chapter 2. The topic is function and the graph. And here is the example of Chapter 2 homework. Examples of Chapter 2 homework. Here, this is examples. First question. Examples. For the following graph of a function f, x-axis and y-axis, and this is a graph, a curve. Ask you find a, find the function value f of -1. This is f of x equals y value. X is -1, so on x-axis, 0, 1, 2, 3, 4, positive. On the left, negative. -1 here. From x equal -1, we are looking for f of x. X is -1 equal what? Y is what? So it's go -1, and then on the curve is this point. On the curve, x coordinate is -1. And y coordinate is 2. So we call f of -1 equal 2. F of 1 equal what? 1. X coordinate is 1. And then go on the curve is this point. This point, x coordinate is 1. Y coordinate is 1. So we put f of 1 equal 1. The next, f of -4 equal what? So on x-axis, -4 here, and go up on the curve is this point. And that point, x coordinate is -4. Y coordinate is 3. So f of -4 equals 3. F of 2 equal what? So it's x coordinate is 2. Is this point on the curve, this point. So this point, x coordinate is 2, y coordinate is 0. 2, 0. So f of 2 equals 0. Then next one, find the domain of f function. This is f graph. Y is equal f of x. F is the function name of the function of x. Domain is x. What is x? X is from 2. From 2 go left. You have the curve because curves go left. So go to the right. There's no graph, no function. So it's to the left. From 2 to the left. So it's less than or equal to. And put it in interval notation. Here say use interval notation from this side is negative infinite up to 2. So it's from negative infinite, put 2, including point 2, use bracket. This means x less than or equal to. Use interval notation. This is x such that x less than or equal to is equal to this. This is interval notation. From negative infinite up to 2, including point 2. If I have an equal sign, use bracket. Use bracket. That's for the domain of this function. The next one, find all the possible value of x for which f of x equal 2. So this is f of x is y equal 2. So you go through 2, y equal 2, and draw and just meet 1 point. 1 point, and that x coordinate is -1. So this is y. And what's x coordinate? X coordinate is -1 because f of -1 equal 2. The point is -1, 2, which is this point. This is x coordinate, and 2 is y coordinate. What is y coordinate? It's f of x. And find the range of the function. Range is y value, function value. The y value for this curve, y value is up to 0. Below 0, there's no curve, no graph, no function. So it's up to 0. So it's greater than or equal 0. Y such that y greater than or equal 0. And the answer in interval notation is including 0, use bracket, up to positive infinite. From 0 up to positive infinite, including the 0. So because this point is 2, 0, up to 0, this is a curve can keep going on to infinite. So it's up to positive 0, positive. Another example, if the graph like this and started over here, x's coordinate is -3, y coordinate is -2. So this point, starting point is -3, -2. Up, go up. So ask you, what is the f of -3? So at -3, y coordinate is -2. So f of -3. X coordinate is -3, y coordinate is -2, so it's -3, -2. And what is the f of -1? At -1, this point, x coordinate -1, y coordinate is -1, so it's f of -1 equal -1. What is f of 0, which is this point? This point is 0, 0. F of 0 equals 0. What is f of 1? So it's 1. And up to here, this 2. So this 1, 2. So f of 1 is 2. What is f of 2? So from 2 and go here and go this point. X coordinate is 2, y coordinate is 6. So f of 2 equals 6. And B, what's the domain of this? Domain is from here for x go from -3 to positive infinite. Is x such that x greater than or equal -3, including -3. So use bracket. That's a domain. And the range is a function value. Then C is a f of what? X equal 2. So at 2, you draw this and just encounter at this point, the x coordinate is 1. So it's f of 1 equal 2. So what's x? X should just 1. And what's the range? Range is y value. It's above -2. Above -2 have a curve, have function. So it's greater than or equal -2. So range is y such that y greater than or equal -2. So it's including -2, use bracket to positive infinite. Another example, like this graph, go down. Started at this point. This point, x coordinate is 0, y coordinate is 5, 0, 5. And then question ask you, A, what is the h of 0, which is 5? What is the h of 2? So this point, 2, 4, 2, 4. So f of 2 is 4. What is f of h of 3? This h is a function name. 3, 2, 2. So is f of h of 3 equal 2. What is h of 4? 4, -1. So this point, 4, -1. So it's h of 4 equal -1. And what is the domain? Domain is from x for this curve, for the x has to be to the right. It's not to the left, because to the left there's no function, no graph. So it's to the right. X has to be greater than or equal 0. Started at 0 up to here. Have a curve. So it's including 0. Use bracket. And what is the range? Range is y value. Y value is down 5. Y is 5. Function value 5. Down 5 and above 5. There's no curve. So it's from negative infinite up to 5, including 5. So use bracket. Then example 2. Also graph. This is absolute value graph. This absolute value graph. And your homework is this V shape here. I erase it and change to this as examples. So determine whether the graph represents a function. In order to determine it is a function, what is the function? A function is every element in the domain have one and only one element in the range as correspondence. For every x, there's only one y, we call function. Like this is input x map to y. This is output. And this side is the domain. And this side is the range. So for example, if I have 1 map to 2, and the 3 map to 4, and the 5 map to 7, this is the domain. This is the range. This is one function. That's what first example. And the second example 2, like if I have 1 map to 2, and 3 map to 2, and the 5 map to 7, and this is domain. This is range. And another examples, for example, if I have 1, 3, 5, and 1 map to 2, and 1 map to 4, 3 map to 4, 5 map to 7, this is domain. This is range. And the three function, for every element, for this we call relation. Relation. The three kind of relation. Three kind of relations. For every element in the domain, there exists one and only one element in the range as correspondence. So like this is a function. Like for every element, like 1 have only one image, 2, 3 only one image, 2, 5 has only one image, which is 7. So every element in the domain, there exists one and only one element in the range as correspondence. So this also a function. And this one have a 2 image, 1 map to 2 and map to 4. So it's not every element in the domain has only one and only one image as correspondence, because 1 have 2 image. So this is not a function. So there's we call vertical line test. In order for the graph is a function, if you have used vertical line, draw the vertical line, every line, every x, there's only one y. If you encounter with graph at exactly 1 point, just 1 point, then this graph is a function. Now, if you encounter with graph at more than 1 point like this, for every x have 2 y, that's not one-to-one correspondence. For every x has 2 image, it's not satisfied definition of function. So like this graph is not a function. So for this question, in order to determine whether this absolute value graph, absolute value function, it is a function, use vertical line test, encounter with graph exactly 1 point. The line encounter with the graph exactly 1 point. So it is a function. If it is a function, find the domain and the range. Domain is x. X is because the curve, this graph can be extended, so it's all of R. So domain is all the real numbers R. And the range is function value y. Y, you can see this is above 0, have a graph, and below 0 has no graph. So y value has to be positive, greater than or equal 0. So range is y greater than or equal 0. Another example like this, this graph. Second question, another example. If a V shape and open downward V shape, this is also absolute value function. Use vertical line test. Encounter with graph at exactly points. So use vertical line test. Yes, it is a function. The range, domain and the range. Domains come from x-axis, x coordinate. Then this can be extended So then cover all the x. So it's all domain is all the real numbers. R means all the real numbers. You can put R, or you can put is the same as this. All the real numbers. All the real numbers. The range you can see is below 1. Y value below 1. Above 1 has no graph. So the y has to be less than or equal 1. You can put this notation, or if you use interval notation, is go from net infinite up to 1. Interval notation, net infinite up to 1, including 1. And then next example, if the graph like this, use vertical line test, encounter with more than 1 points. So this x has 2y. Then that's not satisfy the definition of functions. So use vertical line test if encounter more than 1 points. It is not a function. Then another one, this is still question 2, example. This still question 2, example. Another one, if graph like this, is this a function? Yes, you can use vertical line test, encounter as graph at 1 point. It is a function. Domain is for x to the right of -2. So it's from -2 go positive infinite. So it's greater than or equal -2. And the range is go from for y. Y has to be positive. Y greater than or equal 0. That's the range. And question 3, example. Here, the distance d in miles that Ty is from his parents' house in Denver is given by the function d of t. D of t equal. Now I change example. Example 600 minus 60t, where t is the number of hours since he left his home. What is the domain of the function? Answer in interval notation. So I give you this example. And for this example, you can, it's from his home. Ty, if given d of t equal to this one. Given your homework question, d of t is this. So I change to this. Is 600 minus 60t. And find the domain of this. This linear function. This d is distance, means distance. Function name d. T is in how many hours. So this is Ty's home. And this parents' home. So when t equals 0, is 0 hours. Ty is at home, at Ty's home. And then per hour travel 60 miles per hour. 60 miles per hour. So after 1 hour is after t equal 1 is start at 0 is 60 miles, and t equal 2 and 120 miles, and t equal 3 180 miles, and t equal 4 240 miles, and etc. Keep going on until how many hours you can reach the parents' home. After how many hours can reach the parents' home. So when t equals 0, if you use this this formula, when t equals 0, you plug it in. T and the distance of t. When t equals 0, this is 600 minus 60t. When t equals 0, plug it in is 600. So away from parents' home is 600. So the distance between Ty's home and the parents' home is 600 miles. And when t equal 1, and this distance is 60 miles, so is t equal 1 minus 60 times 1, so is 540 miles. So that's 60 miles, and then this distance is 540 miles. So after 1 hour times here, then away from parents' home is 540 miles. When t equal 2, another 60 miles travel, then times here, so is and the total travel for 120 miles and remain 480 miles. So is away from parents' home is 480 miles. So it's keep going on. When arrive parents' home, that distance, this is a distance from the tie away from parents' home. So it's when arrive parents' home, this distance should be 0. So you let that distance function value equal 0. And what is the d of t is this one. So that means 600 minus 60t equals 0. And you solve for t. Solve for t, move this over 600 minus 60t. And divided by 60, both sides cancel. So you will get t equal 10. So after 10 hours, the tie travel 10 hours. Each hour is 60 miles per hour. Travel total 10 hours. Total travel 600 miles. That arrive at parents' home. So hours t can be from 0 up to 10 hours. You cannot be beyond more than 10 hours. And start at 0, but not including 0, because when t equals 0 is at Ty's home. Here say t is the number of hours since he left his home. Since he left his home, so it's not including t equals 0. So so this question, you let d of t equals 0. Solve for t is 10. So domain, that is what is the domain of this function, which is t. T is for the domain, just like x. T. So it's from 0 up to 10, including 10 hours, but not including 0, because t is the number of hours since he left his home. So it's not including he at home. But t equals 0 is at home. So it's not including 0 up to 10 hours. So this is the domain. So another example, like this question, question 3 example, it's is d of t equal 715 minus 65t. So this is question 3 example is d of t equals 715 minus 65t. If this linear model, and what this means this and Ty's home is here, and his parents' home is here. When t equals 0, Ty at home, and that distance away from parents' home total 7. You let t equals 0, plug it in. This distance away from parents' home is 715. T equals 0. That's 0. So total distance from Ty's home to parents' home is 715 miles. And then travel 65 is 65 miles per hour travel. And so after 1 hour, t equal 1, then distance become 715 minus 65 times by 1. That's the y value. That's the distance value. So it equals minus 65. So remain 650. So away from after t equal 1 hour, ties here. So away from parent home is 650 miles. This distance is the ties location away from parents' home. How much? So like t equal to, after 2 hours, another 65 miles. So t equal 2, then it's 117 minus 60 times 2. So it's 7 minus 130, total 130. So minus, so remain 585 minus 65. Yeah, 585 miles. So it's after another 1 hour times here. So away from parents' home, it's 585 miles. Keep going up until arrive at parents' home. Arrive at parents' home, the distance of time away from parents' home is 0. No distance anymore. So you let this distance equal 0. Let d of t equals 0. Solve for t. So distance of t is this function. 715 minus 65t equals 0. Solve for t. So you got 65t equals 715. Then t equals 715 divided by 65. Divided. 715 divided by 65. And you will get 11 hours. So after 11 hours travel, t equal 11. So domain of this function is start at 0, but not including 0, because when t equals 0 is at home. Here say t is the number of hours since he left his home. So don't including 0. And up to 11. That's those hours between 0 and 11. Those hours, that is the t. That's those hours since he left his home. That's the domain of these functions, and those is use interval notations. Next, question 3. Another example. If a given distance function like this, distance of t equals 651 minus 62t. That means this one means from Tai to parents' home, total distance is 651 miles distance. Each hour travel 62 miles per hour travel. And when arrive at home, that distance is 0. So you let 651 minus 62, t equals 0. Solve for t. So you got 62 equals 651 and divided. So the 651 divided by 62. Divided 651 divided by 62. 1, 62, 3, bring down 0, 0.005. So equals 10.5. So after 10.5 hours, total travel 10.5 hours, arrive at parents' home. Since he left his home, started not including 0. And so the hours you can plug in is between 0 to 10.5 hours. Those hours that's he can travel. He will travel. Then question 4. Example. If given a function like this we call piecewise function. Piecewise function. And then and this piecewise function is this is an example. If x is negative less than 0, use this function negative x squared. If x is between 0 and 7, including 0 and 7, use 2x minus 3 function. If x greater than 7, use x plus 4 function. Now, number 4, examples. Ask you f of 6. So 6 is less than 0. No. 6 is between 0 and 7. Yes. So use this function. Put in 6 greater than 7. No. So it's the second one. So the 2 times 6 minus 3 is 12 minus 3 is 9. Then f of negative 2. Negative 2 is in x. So check x is less than 0. Yes. Is negative. Less than 0. Yes. It's not between 0 and 7. It's not greater than 7. So use first function. First function is negative 2 squared. Negative 2 squared is 4. In front have a negative sign, so answer is negative 4. F of 9. 9, you check it. 9 less than 0? No. 9 is between 0 and 7? No. 9 is greater than 7? Yes. So use third function. 9 add 4 gets 13. 9 plug into the third function. Then f of negative 3. Negative 3, you check the 3. Negative 3 is less than 0. True. So use first function. So you plug in. Plug in, you will get it's here has in front have a negative sign. Then x use negative 3 plug in. So negative 3 squared is 9. In front have negative sign, so it's negative 9. F of 0. 0 is here. X greater than or equal 0. It's not in first because the first one doesn't equal 0. So the second one greater than or equal 0. So use second function. 2 times 0 minus 3. 2 times 0 is 0. Minus 3 is a negative 3. And the f of 3. F of 3. 3 is x is between 0 and 7. It's not less than 0. Not greater than 7. It's the second one between 0 and 7. So 3 plug in. 2 times 3 minus 3. 2 times 3 is 6. Minus 3 gets 3. F of 11. 11 is greater than 7. It's not less than 0. It's not between 0 and 7. It's the third one. So use third function. 11. X use 11 plug in. 11 plus 4 is 15. F of negative 4. Negative 4 is negative less than 0. So use first function. Plug x by negative 4. In front have a negative sign. It's a negative. This negative 4 squared becomes 16. In front still negative sign. So it's a negative 16. This we call piecewise function. Piecewise function. And question 5. It's the Liberty paid. I changed the number. This is an example. And your homework is $220. I changed to $200 for her form. So she paid $200 for form. Add per month service is $45. And after T months service. So formulate a linear function cost, total cost, to model the C of T function for T months. So like T equals 0, then you just pay $200, 45 times 0. So add 200, it's $200. That's you pay for form. After 1 month, you 45 times 1, T equal 1. That is $245. After T equal 2, after 2 months, 45 times 2, 2 months. So it's $90 service fee. So $290. If T equals 3, after 3 months, 45 times 3, add 200. So this we call after T months service. Each month cost is service fee is $45 times T months. Add original phone fee is $200. That's total cost. This we call cost function. Determine the amount of time required for the total cost reach $650. So that's cost becomes $650. Becomes $650. So you let C of T equals $650. So C of T, example 5. C of T equals 200 add 45T. Ask you, after how many months T, the cost becomes $650. So use $650 plug into the cost. So become this 200 add 45T total equals $650. Then you minus 200 both sides. So you will get it's 45T equals $450. And then divided by 45. Cancel. So you got T equal 10 months. After 10 months, total cost is $650. It's very, you can see total cost is $650 and you pay $200 is for the phone. You buy the phone is $200 and remain $450. That's for monthly service fee. And each month is $45 and you will be 10 months. So answer is 10 months. After 10 months. So that's question 6. Classify the functions. Classify the functions. There's a degree is 1 we call linear function. The function, if given the linear function is f of x equals mx plus b. This is slope-intercept form. Degree is 1 we call linear function. Quadratic function is f of x equals ax squared plus bx plus c. Degree is 2. We call quadratic function. Degree 2 we call quadratic function. And the rational function is a fractional form, like ax squared plus bx plus c. Numerator is a polynomial. Denominator is another polynomial. Then we normally put this way: p of x over q of x, where p of x, q of x are polynomial. For example, like f of x, as long as in fractional form, like x plus 3 over x, as long as put in, that's we call rational function. Rational number means a fraction. We call rational number. As long this is a fractional form, we call rational function. And the absolute value function. Absolute value function, it's has absolute value sign, like f of x equal absolute value of ax plus b. Have this bar, we call absolute value function. So A example is f of x equal 2 minus x over 3 plus 4x, fractional form. So we call rational function. And find the domain of the function. Domain is what's the number you can put into the x. The x is domain. So this domain you can put in any real numbers except the number make denominator equal 0, because we cannot divide it by fraction. You divide it by 0, like 2 over 0 is undefined. It's undefined because 2 over 0, if you have a value, then what's value times 0 go back to? There's no such value. Any number you times by 0 is 0, never go back to 2. So there's no answer. So it's undefined. So you let denominator 3 plus 4x equals 0. Solve for the x. And let denominator 3 plus 4x equals 0. Solve for x. 4x equals -3. Divided by 4. X equals -3 over 4. So get x equals -3 over 4. So domain is all the real numbers except -3 over 4. So we put in this form. We put this form. R minus -3 over 4. This form. You also can, this is equal all the real numbers except -3 over 4. And you can put this way, x such that x belong to R and the x is not equals 3 over 4. You can put this way or this way or this way. You also can put interval notation way from -infinite to -3 over 4. Open union with -3 over 4 to positive infinite. So you can put, the simple way is put this way. Now, second example, this is also a rational function. As long as in fraction, we call rational function. What's domain? Domain is the number you can plug in x, but you cannot make denominator is non-zero. So you let denominator equal 0, solve for the x, get x equal positive negative 2. That make denominator equal 0. So it's all the real numbers except positive negative 2. So we put this way, R is a set minus another set, has two number, positive negative 2. And for this one, 2 over x squared plus 1, also fractional form. It's called rational function. And what's the domain? Domain, x squared is always positive or 0, add 1. Never equal 0. Because any real number, you square it, is going to be positive. You add 1 is greater than or equal 1. So never equal 0. Like x squared is greater than or equal 0. Then you add 1. And you will get x squared add 1 greater than or equal 1. Never equal 0. Never. Greater than the denominator minimum is 1. Greater than or equal 1. Never equal 0. So you can plug any real number in x. Make denominator non-zero. And 2 divided by non-zero have a function value. So this one is domain is all the real numbers. Denominator never equals 0. Then next one, question 6b is h of x, h function. Example 6b. This question 6b. Given you h of x equals 3x squared minus 3 square. Degree is 2. We call quadratic function. Quadratic function. What's domain? Domain is what's the number you can put in x, have function value. That's all those numbers together we call domain. So you can plug any real number in. So domain is all the real numbers in x. So this one B, another example, h of x equal x squared minus 2x plus 1 is also quadratic function. Degree is 2 is quadratic function. Domain is all the real numbers. Another example like x squared plus 3x plus 4. So degree is 2. This is also quadratic function. Domain is all the real numbers. And the C, g of x equal 2x minus 5. Degree, that's your homework question. Example, g of x equal x minus 4. Degree is 1. And that's the linear function. Domain, what's the number you plug in x, make function have value. X can be all the real numbers, so domain is R. And g of x equal another example, 1/3 x minus 8. This degree is 1, also linear function. Domain is all the real numbers, R. Like another example, k of x, the function name is k. K of x equal absolute value is 7 minus x. This we call absolute value function. What is x? What's the domain? You can plug any real number in x, always have function value, so domain is x. The other one is k of x equal absolute value x minus 1/2. This also absolute value functions. Domain is all the real numbers. Question 7, draw the graph of these functions. Graphing. I changed this example. F of x equal 1/2x minus 3. So you can figure out like x equals, this is y. Y function value is y. Y equal 1/2 x minus 3. You given x as 0. 0 plug in. 1/2 times 0 is 0 minus 3. You got y is negative 3. So 0, negative 3. That's y-intercept. Y-intercept. Then you given y equals 0, equal 1/2 x minus 3. And move 3 over, get 3 equal 1/2 x times 2. You get x equals 6. That's 6 is x-intercept. Actually, you just need the 2 points. And connect the 2 points, use the ruler. And you got the line. And you can also find other points like x equal 2, plug in 1/2 times 2 is 1, minus 3 is negative 2. like x equal 4, 1/2 times 4 is 2, 2 minus 3 equal -1. Like x equal 8, 1/2 times 8 is 4, 4 minus 3 equal 1. Like x equal -2, 1/2 times -2 is -1, minus 3 is -4, and plug those points. 2, -2, this point. 4, -1, x is 4, y is -1, so this point is 4, -1. 8, 1, 8, 8, x is 8, y is 1. Like -2, -4, -2, -4. They are on the same line, those points on the line. And the other one, like given the domain and the range. So this question, linear function, degree is 1. Linear function is domain is all the real numbers, and the range is also all the real numbers. Domain and the range, all the real numbers. Because x, you can plug any real number in x. Y, also all the real numbers. And this y equal a constant function, y equals c, is a horizontal line. Like this y equals 3. Constant function. F of x equals c. C is a constant. For example, f of x equals c is 3. Then go through 3, draw horizontal line. It's the graph. And the domain is all the real